Hello, my name is Onur Çetin. I'm a third year student in Electrics and Electronics Engineering, and I try to talk about root locus. Root locus is a graphical method in control theory, and we look at the change of poles and zeros according to changing k value in the system. This should be zeros actually. And I solved an example. As you can see, firstly I this function and I found the poles and zeros and their numbers, so I can find the number of branches, asymptotes, and the asymptotes angles. And as you can see from this graph, I put the poles and zeros, and I select the branches as you can see. I select like that because there should be odd number of poles and zeros at the right. So in this branch I have only one pole, and for this branch I have 1 0 and 2 roots, two poles in a total of 3. And I should find these separation and merge points, or I should say break away and break in points with this formula, and I should check whether k is bigger than 0 or smaller than 0. And I can find these k values for these points. And it is important also for the intersection points with the j omega axis or imaginary axis. So we can find this in two different ways. One of them is replacing s with j omega in this equation, or the other way is Rath-Hurwitz criteria or method. And we can find this omega and k values for this imaginary axis. And root locus is different than Rath-Hurwitz method because we can find settling time, rise time, peak time, and overshoot, and also dominant poles. We have information about them with the help of root locus after drawing this graph. For example, maximum overshoot happens in the top of the circle because angle is the maximum, where we know that the angle is proportional with the overshoots, and we try to select smaller values in order to set the settling time smaller. And thanks for listening to me.